This is Malaram. I will going to teach you complex number, and I have 1 year experience in that field. Next slide start complex number. So before that complex number, I introduce to real number like real number. Real number we can represent or we can write anyway, and we can fundamentally represent real number like it is a one subject like anyway, and this ideal number we cannot conclude it is one like this difference between real number and imaginary number. That's before taking a simple equation like that x square plus 2x plus 1 is equal to 0 means we can rewrite it by this is equal to 0, and so that's x is equal to x plus 1 is equal to 0 means value of x is equal to minus 1. This is a real number, and let's take another example. X square plus 1 is equal to 0. So the value of x will be square root of minus 1. This is impossible, fundamentally impossible. So solve this type of equation which have an square root of any negative number. Because of this, complex number introduced, and so let's take parts of complex number. We represent complex number by a variable z. In this z, real part plus complex of imaginary part coefficient. Yeah, these parts. Here, one thing I mentioned here, A and B is real number, and is iota. Iota is square root of minus 1. Iota is the square root of minus 1. It is a complex coefficient. We can say represent this square root of minus 1. Yeah, and we can say I square is equal to minus 1, and likewise I cube is equal to I square into I is equal to minus iota, and I 4 is equal to plus 1. Likewise, repeat the same process in terms of iodine 4. Okay? This is another example. Now take this z. So all set of z like complex number variable z1, z2, z3 like z. This set of all complex number variable z is denoted by C, a complex number. This set of all complex number variable is denoted by C. Yeah. Now I conclude about this complex number is Z. A is equal to I plus I into B in this here. This part called real part of Z is A, and imaginary part of Z represented by I and Z is equal to B. Here B and B are here, I told you. If real part of Z, if real part of Z is equal to 0, part of z is equal to 0, then complex number z to be iota b purely imaginary. ठीक है? And if imaginary part of z is equal to 0, then complex number z is said to be pure real. Like I take some example where we can confuse of like this. But before that, I want to tell you complex number 0 plus iota 0. It's also both pure real and pure imaginary. It's one complex number is both pure real and pure complex number. And before that, I conclude that complex number z. Two complex numbers z1 take a plus iota b and z2 z2 is equal to c plus iota b. Then complex number z1 and z2 are equal only and only this imaginary parts z1 is equal to z2 if and only if a is equal to c and b is equal to b. Now take some example. That's showing that z is equal to minus 17i. It's a complex number. Purely against and third one is real number. Here option is like this complex number. We cannot say its one part is 0 z. Next, some other example like z is equal to 7. We can say it is pure real number like this. Now I am teach you some property of this complex number and property. Algebraic property means this two complex number z1 is equal to a plus iota b and z2 is equal to c plus iota d. And first property is addition. The complex number are added in same format like real number. Real number added with real number and complex number added with complex number like z1 plus z2 is equal to a plus iota b plus c plus iota d. Here a plus c plus iota b plus iota d. A plus c iota b plus d. So it's a real part of z1 plus real part of z2. It's imaginary part of z1 plus imaginary part of z2. Like in this way, second property is addition, subtraction z1 minus z2. Like in this Z1 minus real part of Z2 plus imaginary part of Z1 minus imaginary part of Z2. In this way, third is multiplication. Z1 into Z2. Z1 A plus iota B and C plus iota D. AC plus AD plus iota BC plus BD or iota की power. Iota की power is called B minus 1. एक minus 1 because 5 हो गया.